Okay, day 3 in 5, 4, 3, 2, 1, and we're off. Alright, or day 4, wow. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of their assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair, your input. For example, consider the following list of section assignment pairs: 2, 4, 6, 8, so on. For the first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2 to 4, 2, 3, and 4, while the second elf was assigned sections 6 through 8, sections 6, 7, and 8. The elves in the second pair were assigned each 2 sections, 2, 3, and 4, 5, and the elves in the third pair were assigned 3 sections. One got 5, 6, 7, and the other one got 7, 8, 9. Okay. This example list uses single-digit section IDs to make it easier to draw. Your actual list may contain larger numbers. Visually, these pairs of assignments look like this. Okay, great. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 through 8 fully contains 3 through 7, and 6 through 6 is fully contained in 4 to 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning, so this seems like most in need of reconsideration. In this example, there are 2 such pairs. And how many assignment pairs does one range fully contain the other? Okay, so let's grab our test input. And then let's grab our actual input over here. Our test input 2. We're looking for 2. Alright, so we're looking for 2 in the first one. Okay, so alright, we know we want to return the total overlap, which we need to keep count of. And then, like before, what we're going to do is break it down by line. So for line in input, and then what we first want to do is we want to split it on the height or on the comma. So to break it into 2 elves. Line that split on the comma. And then this time we're also going to try to just use a map, make it a little bit more Kotlin-y each time. And then for that, so what a map does is basically for every item in the list, we're going to do some sort of additional work and save that as a new list. In this case, what we want to do is split it again, and it just is the iterator. It basically says that means each item as we go through. So we're going to split it on the hyphen, and then we're going to map it again. And so this map is going to be on the string representation of the number, of both numbers for the left and right of the range. And then we'll want to do that to an int. Why is it yellow? Doesn't matter. Okay. And then for each pair of ends, so we'll go back up to the main mapping, we're going to map it again. And so this is going to be for the outer list, which is going to contain a internal list of just 2 elements, the lower end of the range and the high end of the range. And we're going to want to make it into a set. The easiest way to do that is going to be the low value and then ... the high value. And we did this yesterday too. This is going to basically create a range If you use a dot dot, it will include everything from the low number to the high number, including both ends and just integers, and you can do like stuff like that. And we want to do that to, may have to, yeah, there we go. Okay, so this is going to create a range. So like basically if the low value is 4 and the high value is 6, in here, we're going to make a range that is 4, 5, and 6, and then we're going to turn that range into a set. A set just means that is a collection where every item is represented at most once, but it allows us to do a lot more operations and stuff on it. And then basically what we want to do is want to make sure that everything in the first set is included in the second set, or vice versa. And we can use the intersect operator, probably the easiest. So if elves 0 intersect elves 1, so this is going to return back a new set of everything that's in the first set that is also in the second set. If that one dot size is equal to, actually I don't even need to do size, we just say if it's the same set. Yeah, that'd be easier. And then we'll want to do the exact same thing, but for our second elf. Oh, this is not elves, this is going to be L always fail. Elf 0, that's 1, and we'll just swap these back and forth. So if everything in the first, if you take everything in the first set and you take out everything that's not in the second set, if it's still equal to the first set, then the first set is wholly contained in the second set. And then the exact same thing on the second line in reverse. So if that happens, then total overlap plus plus and just return total overlap. And then let's see. Okay, so 433. Okay, that's the right answer, and continue to part 2. It seems like there's still quite a bit of duplicated work planned. Instead, the elves would like to know if the number of pairs that overlap at all. In the above example, the first 2 pairs don't overlap, while the remaining 4 pairs do overlap. Overlaps in a single section, 7, okay. So in this example, the number of overlapping assignment pairs is 4. How many assignment pairs do the ranges overlap? Okay, so this is going to be similar. Okay, the second one, okay, it should still be similar. So I think we're just going to take everything in the first one, paste it in here. And the difference is now we don't care if they're exactly overlapping. We care if there's any, so if there's any items in this set, so we can say it's greater than 0, or that size is greater than 0. It's probably going to tell me use is not empty or something. Yeah, it's not empty. Okay. So that is not empty. So this would be if there's any item in the first set that is in the second set, or vice versa, then we increment. I think that's all we need to do. Oh, I need to update that to 4. Cool. All right. And there's our answer. Submit a 52. Okay. We completed day 4, and I'll see you guys tomorrow.